Hey mechatronics students, this is Andrew Dahlen, and we're talking about the vertical mill today. This video we're going to talk about how do you take a chunk of material and get it square. So this piece of aluminum has been cut. The edges are pretty rough. It's been cut with a bandsaw, and you can see that a bandsaw is not going to leave a very clean cut, and we don't know if this is square, and it's probably not the right size. So where we start with this is, the mill is great for taking off smaller amounts of material. So in general, if you needed to make let's just say that this is 4 inches in this direction and 10 inches in this direction. If you needed a 4-inch by 10-inch block, you would start with something that's maybe 10 1/8 in length. So it's a little bit longer, not too much. And likewise, 4 1/8, so that we can just clean up these edges using the mill. So to get us started, we're going to use this guy. It's called a face mill. And this cutter is one of my favorite. It has carbide inserts in here that are adjustable, so if this gets dull, starts to wear out, we can replace or rotate the inserts and keep it good and sharp. So this one has got the R8 collet, so it goes directly into the spindle, and we can go ahead and start by installing that. And again, we always want to be careful when we're using these cutters and handling them, because these tips, although they're incredibly sharp and hard, they're very brittle, and if we were to drop this, there's a good chance we're going to break some of the inserts. And depending on the cutter style, each insert could be $20, or some of these inserts are upwards of $100 for some of the more expensive ones. So to start with, we're going to go ahead and remove any collet that's in there. All right, and we're going to install our face mill inside the mill. Again, rotate it till we find that sweet spot where the key is, and we go ahead and tighten that up. Okay, grab our wrench, apply the brake. Okay, doesn't need to be, again, super tight, just get it snugged up inside the spindle. The collet's going to hold it in place quite well. Now, this particular cutter is about 2 inches in diameter. So when we're calculating these RPMs for this, if we were to run through the formulas here, we're going to, we're cutting aluminum once again, so the surface feet per minute is going to be 300. And one of the differences is that this cutter is using carbide inserts, and one of the little notes in here that says double the speed if you're using carbide tooling. So in this case, surface feet per minute is 300 times 12. That gets us our 3,600, and I'm not good at the math here in my head, so we're going to pop out a calculator. 3,600, and then diameter times 3.14. Well, it's a 2-inch diameter, so I'm just going to estimate it and say 2 times 3.14. Well, that's 6.28. So pop the numbers into the calculator here, and I have 3,600. Oh, clear everything. 3,600 divided by the 6.28. And this says the spindle speed should be, RPM should be 537. Well, because it's carbide tooling, we're going to double that. So we're going to go about to, double 570. We'll just make it 550 and go with 1,100 RPMs. So it turns out we've got it already set up for 1,100 RPMs. And we're going to go ahead and start the process here. So this block has got 4 edges to it that we need to clean up. So the process would be to start with it just a little bit oversized, maybe a 1/16 to 1/8 oversized, and then do a cleanup cut on this top surface. And it doesn't matter where that's sitting. I would just put it flush on the vise and then take a pass, clean up that cut. Then we're going to flip it over and make sure that that cut we just finished is sitting nicely against the bottom of the vise. I want to make sure there's no chips in there that would potentially kick it up to one side or the other. Make sure that the vise is clean, and we reference that edge in order to cut the top edge and get it to an exact dimension. All right, so let's demonstrate this. So first of all, we're going to clamp it up into the vise, standing on edge. That vise was out quite a ways from last time, so "4 hours later." All right, so we've got it clamped up. Our work area is free of any sort of extra stuff, and we're going to take and make sure that our guard is installed because the chips are going to fly. Okay, so let's get a nice close-up view of what's happening here. Adjust this guard so you guys can see it. Okay, that should be good. I'm going to bring, I have a couple options. I can bring this down. That's probably an easy option. Get it locked into position with the spindle lock. And we're going to take our handle for the vise, cast that aside. Okay. So I'm a little bit above, about a 1/4 inch above the surface right now. It is free to rotate without any worries. And with this being aluminum, we can use, actually a WD-40 is a decent cutting fluid for this. So hang on just a second. That helps to keep some of the chips and stuff out of there. If we use a little bit of WD-40 across there as a cutting lubricant for the aluminum. And we're gonna, it's lined up so the face mill is right about in the center. So we're gonna go ahead and take our first cut here. Make sure the rotation is correct and the RPMs is correct. So we can see it's turning to the right. That's gonna give us our right hand cut. And we're just gonna bring up our knee. All right, so it's just starting to make that cut. And you can see how uneven this is right now. We can take off about 50 thousandths of an inch at a crank. That's about a 1/4 turn. I'm sorry. On this one, 50 thousandths of an inch would be about a 1/2 turn of the knee handle. All right, you can see how uneven this is because now it's not doing any cutting. And it's starting to engage again at the end. Okay, so we took our first pass and it did not clean up the entire cut. So I'm just going to come over here, give it a little bit of lube across there. And with this face mill, I can actually run the cutter back and forth and it seems to work pretty well for me. So I'm going to raise the, raise up the knee about 50 thousandths of an inch, and it's got these markings on it. Each mark is 1 thousandths, so about 1/2 turn on this knee is going to raise the entire thing up 50 thousandths of an inch, and then we can go ahead and take our second cut across there. All right, so that did a great job. We'll take a look at that cut. It's clean all the way across. Pretty happy with the cut performance that we have on that. Excellent. So we want to make sure that the spindle has completely stopped before we put our hands anywhere near this, and we'll take a peek at what we've got. It's a nice clean cut though. Loosen it up, pull it out of the vise, and you can see we've got a nice clean cut all the way across this surface, and it's got a bit of a burr to it, so we can clean that burr up using a file. Fun fact, files only cut in one direction. You could also use a deburring tool, and I'll demonstrate the deburring tool in a little bit here too. Okay, so again, that's going to give us a nice little beveled edge across that. Excellent. So there we've got a nice clean cut on one surface of our block. Now, like we talked about earlier, we want to take that and put it into the vise and make sure that the vise is clear of any chips that are in here, because we're referencing the cut surface that we just cut in the bottom of the vise. So we want to make sure that it's nice cleaned off, the vise has got no debris, no chips in it. Then we're going to slide that cut surface into the vise and use that as our reference point. This is all squaring up our block. All right. So now that that's clamped in there quite nicely, we can go ahead and make a cleanup cut in here and get it to our final dimension. So let's go ahead and do that. I'm not 100% sure on the use of WD-40 as a cutting fluid. The Tap Magic works really nicely too. We can just apply some of that across there, and that is going to help us get some cutting fluid into our locations. So here, the last time we did this, we were at we kind of had it zeroed out, so I would go ahead and raise the knee up by another 50 thousandths, so we can crank that handle about half a turn. That's a pretty heavy, a nice heavy cut on here. Get it fired up, and let's take a look at this action. All right, so that looks terrific. At this point, I'm kind of curious about our size. So I just grabbed this and we're just arbitrarily showing what our setup would be. So we'll zoom out here a little bit. Oh, wrong way. And we'll talk about the size. So if it's sticking out here, we can use our caliper to get a measurement and see what our overall size is. This one is 3.892. 3.892. So if we were shooting for 4 inches, we already screwed up. 3.892. If we want to get it to an exact size, we can use the knee here to bring it up slowly, taking no more than 50 thousandths at a time. And maybe for the final cut, actually I'm pretty happy with the surface finish that we're getting here. So yeah, we'll just call it there. If we want to adjust the size, we just take more passes and take careful measurements after each pass. So at this point, we're going to change our setup and talk about how to finish the other edges of the block. So a couple things. We've got 2 edges that are pretty nice and square, and we can clean up our deburr the edges here. All right, so we've got the edges are all deburred, And if we've done a good job on this, we're going to have the same dimensions from one end to another, that making sure that these two surfaces are parallel. So I've got, in this case, 3.895 and 3.891. So it's about 4 thousandths larger on one side than the other. And again, that could just be putting it in the vise and having a little bit of debris underneath there. Maybe it wasn't perfectly set, but I'm pretty happy with that. It's, you know, only 3 thousandths difference from the height here to here. That's less than the thickness of a human hair. So we're happy there. Now, in this case, in order to square up the other ones, if I were to position this inside the vise and stand it up on end, a couple problems with that. First of all, it's going to vibrate. There's a lot of material that's hanging out here. It's not very well secure, so we're going to get a lot of vibration and chatter. And then I have no idea if this bottom cut is square or not. Right? There's a good chance that this could be leaning one direction, I'm exaggerating, or it could be leaning the other direction. I have no idea if this is square relative to this edge. So we want to make sure that this is square relative to the edge we're going to cut. And the best way to do that is to change how we fixture it. And in this case, we're going to use some parallels. All right, go ahead and open up the vise. And instead of putting it on end like this, if we clamp it into the vise and then run the y-axis across here, we're going to be able to make sure that that cut is perfectly or pretty darn square relative to the vise and the mill, and life is good. So we're going to put in our parallels and open up the vise, slide in our stock. Okay, so the parallels are in place, the vise is nice and clean, and we're going to, as we're tightening this up, we're going to tappy tap tap. Okay, the parallels appear to be nice and tight underneath there. So we are set. Clear off any tools that we're using, set them off to the side, and now we can go about cleaning up the end of the block. All right, so I'm going to turn the handle to get our x-axis over, and I suppose we could use the same cutter for this purpose. But if you notice, the face of this cutter is, it's not perfectly straight up and down. It's got some bevels to it, so we're going to have to take it in multiple steps in order to get that cut cleaned up where we'd like to see it. So to do this, I'm going to drop the spindle down and lock it in place. Okay. And then we're going to be making our cuts across this edge. So basically we're going to be taking a cut, then we're going to bring up the knee to raise up our part, take another cut. So it's going to take a few passes in order for us to clean up this entire thing. So we'll get a nice close-up of that business, and I'll pull the dirty shield out of the way and apply a little bit of cutting fluid across that surface to help us. All right, so here we go. We start up the spindle, and pretty happy with that. We're just going to bring this axis in, the x-axis, till it touches, and we'll get a little bit more. Okay, so at this point we can zip across the surface. All right, so we've got one cut done, and now we're just going to raise up the knee by about a full hand crank, which is 100 thousandths, and make another cut. and raise up the knee another 100 thousandths. So down here I'm taking this bottom hand crank and giving it a full turn. That's 100 thousandths every time. And we go ahead and make another cut. Switch cameras here so you get that nice perspective. Cranked up the knee another 100 thousandths. And another 100 thousandths. We're almost through the part here. Almost got one edge completely square. Got one final pass here. All right. So that is looking really good. We've cleaned up all of the edges. It just took some time to make that. So I'm going to swap the cutter out for a different variety. We're going to use a more traditional end mill to clean up the face a little bit more, and then we'll clean up the other edge. So hang on just a second. Okay guys, this is an end mill, and this one's about a 3/4 inch 4-flute end mill. And we're going to use this end mill to clean up the edge of the part. It'll give us a little bit better finish. So we grab the appropriate sized collet to make that happen. And it's a nice smooth tight fit there. So we're going to go ahead and put that in there and use this to clean up the edges of our part. So again, I've removed the old collet. We're going to slide this up and get the new collet installed. And once that's getting a little close to tight there, we can install the end mill. And again, we never want these to fall out. So we're going to always have our hand on there till we get it snugged. There's a possibility we can damage things. And then once it's snug in place, we can apply the brake. And it doesn't take a ton of force to get that installed, and it should be locked and rigid and in place. So that's looking good. We're going to go ahead now and figure out, based on the diameter of this cutting tool, what is the appropriate RPMs of the spindle. So in this case, again, we reference our sheet here, and we do the same calculations that we've done before, but this time for a 3/4 inch cutter. So the diameter is 0.75. Let me clear everything out. 0.75 times 3.14. All right, 2.355, and then 3,600 divided by that number, and we get a speed of about 1,500 RPMs. This is not a carbide cutter, it's a high-speed steel, so we don't need to double the speed. So about 1,500 RPMs, we can go ahead and crank this up, get it to the right speed. Again, the spindle has to be spinning in order for us to get this speed set. So there we are. it's at the appropriate speed, and now we're going to go ahead and take that cut and clean up this edge. So we'll bring our spindle down, lock it in place, and if we need a little bit more, we can raise the knee, get it where we need to go. And we're going to take a nice cleanup pass over here. All right, that's pretty darn close. I'm feeling like we can fire this up and get it going. So in this case, it'd be nice to, again, apply a little bit of cutting fluid across this edge to help us clear any chips that are in the way. And we'll crank this up and get it so that it's just touching that surface. Okay, so I'm pretty happy with that cut. It did a really nice job cleaning everything up. Now you're going to see some marks in there, and if we want to do a better job, we can take what's called a finishing cut, where we just take even less material off for our final pass. So I'm going to go ahead and fire this up, bring it back and forward. So for that final cleanup cut, we're going to take off probably only about 10/1000ths of an inch, maybe even 5/1000. So I'm just going to get some cutting fluid across that surface, and we'll move this in only 10/1000ths of an inch on the dial, or 5/1000ths actually. We'll go 5. And this is going to be a very light finishing cut. All right, that is a beautiful cut across there, and we know that it's square, so life is good. Now normally, I guess I can do that. We would, to finish up the last surface, we've done 3 surfaces, and we have one more that's over here on the other side to do. So we'll zoom out. And I'm just cranking the whole thing over, leaving everything in place so we can get that last surface cleaned up. And then we would have squared up the block. And one thing I haven't talked about is climb milling versus conventional milling. Okay, and I guess a good way to describe this, if I grab a cutter. Okay, you'll notice that when I was over here, that the cutter's rotating in a certain direction. So let me zoom in and show you what we're talking about there. Okay, all right. So I've got a 2-flute cutter here, and when you notice, I was going like this, where the cutter was rotating this direction, and the chips are being I'm moving the material in this direction. The cutter's rotating this way. Okay? That's called conventional cutting, where the direction of rotation is opposite the direction of the travel. Right? Another style is called climb milling, and that would be where the cutter is basically, if I would have started from this back edge, and it's cutting while it's moving forward, right? So there's 2 different methods here, climb milling and conventional milling. And conventional milling is often preferred way to cut things. You find you get a little bit better finish on there. So again, the difference is, we'll have to look up this, I think it's in the Amatrol stuff as well. But when I started on this edge and the chips were going out and away from the cut, as I'm traveling, that's conventional milling. And climb milling would have been more like this, where if I started from this back corner and it was kind of climbing as if these were teeth that were like a wheel engaging. So I don't think that's the best description, but I know there's some better descriptions out there. And I try to do conventional milling most of the time. So we're going to bring this guy down. And again, in order to do our conventional milling, I need, in this case, because I'm on the opposite edge, to start from the back edge and then push my way forward. So that's what we're going to be doing. And I'll adjust our camera so I get a little bit better vantage point there. So we just have one edge to clean up on this part. Apply a little bit of cutting fluid, and we'll get her cranked up. And we're just taking very light passes. Okay, that cleaned it up. There's still a little bit, you guys can't see it on the camera, but I'm just going to call it here and take off 1/10,000th of an inch pass, 0.01 inches. Pretty light cut. And voila, we've squared up our block. So we'll go ahead and take it out of the vise, and we'll chat here. Okay, so we've squared up a block, and to do that, we first started by cleaning up one edge, right? Then we flipped it over, and that cleaned up edge was placed on the bottom of the vise. And with that, we know the bottom of the vise is square, and as long as there's any chips and junk underneath it, we should know that when we take the top pass, that should be parallel to the bottom pass. That's good. Then, in order to clean up the ends of this guy, we clamped it in the vise, and we ran the y-axis and an end mill to clean up the ends and each side, and we'd get it to our final dimensions. But that is the basics of squaring up a block. And if the vise is dialed in and set, we should have a nice square edge all the way around, and our part is then ready for the next step. So that's what we're talking about when it comes to squaring up a block. You guys are going to practice this and have fun. We'll chat later.